Hello there, I'm Dr. Wadhah Shakir. I'm going to talk today about separating the residual field from a total field of a geophysical data. First of all, we are prepared the data within an Excel file, within a yellow folder, anywhere inside the computer, and we try to open the Excel sheet, and we find that we have the grid information, which are X and Y and Z. The X represents the longitude values, and B represents the latitude values, while C is a geophysical parameter, which is even Bourget anomaly in milligal, or magnetic data in nanotesla, or radiometric data in count per minute, etc. As we see here, that the original grid here uh, has about 760 readings, and we are going to make a grid by using the Sufer software. So what we are going to do right now is to open the Sufer software. As soon as get open, then we go to grid key and then data, and we are going to import the data inside the Sufer. And wait, here we have a window which showing that the X values are in the column X A, and the Y values in the column B, Y or Z values in the column C. Here we chose the Kriging method, which is an ordinary and common method and interpolation method in presenting the data for here we have to name the file. Let's name it total Bourget anomaly map data. Okay, save. Just to change the name and add grd, referring to a grid file, then save, then press on OK, and this would create the grid or calculate the grid for the total Bourget anomaly and saved also inside the file or the yellow file. And we can also assure that if we open the file, then we find the grid file here has created inside our yellow folder. So let's go and map this grid. Map, new, contour map, total Bourget anomaly, open. Then the map of total Bourget anomaly is appeared on the screen. The idea is to find a regional field within the total field by using a graphical method, just like what referred by P.V. Sharma 1982, to use the polynomial regression technique in finding the regional field of the total field. So we have to make another grid of the regional fields. So we go to grid again, then data, and the same data of the total Bourget, which saved in the Excel file, then open. And here we don't choose Kriging, we choose the polynomial regression, and the advanced options we use the second order, for example quadratic surface. Okay, and tell them okay, then change the name here and make it regional field, regional Bourget. Grid, and save, then press on OK, the program starts to calculate and create a new grid for the regional field, and we can check this if we go to the yellow folder and find the regional Bouguer anomaly grid is saved either. Now we need to plot the regional field, so we go to map, new contour map, and choosing the regional Bouguer and open, and then regional field has been created and plotted in the plotting canvas. So we can compare, also we can make some profiles, and the total field here referring to the field which is related to the basement rocks and the sedimentary cover which lays over them, while the regional field represents the dense rocks, or let's say the basement rocks, which are the dense rocks in the region. What is required right now is to subtract the regional field from the total field in order to obtain the residual field. So the first step is to save our plotting file. Also inside the file which includes our calculations or analysis for the field, let's say let's name this gravity analysis, and save it in the same yellow folder. Okay, right now I can close it freely or open another files freely. Right now we need to change the format of these two files, which are in a grid format right now, into a XYZ format. So we double click on any file, for example the total Bouguer, a grid file, then it's opened, and it's required to save it as an XYZ, so save as, and we choose here XYZ data format, and we name this file as total Bouguer data file, and we save all files within the same yellow folder in order not to lose them. Then save, we close it, then we open the regional Bouguer anomaly grid file, and save it, save as a data file, XYZ data file, and we name it regional Bouguer data. Okay, unsave, we close it. The aim behind turning the grid files into data files is to do the mathematical operation, which is the subtracting of the regional field from the total field in order to get the residual field. So it's required that Microsoft Excel or Office Excel is installed in your computer. So we'll try to open an Excel sheet in order to do the operations. So at first we have to open the Sufer again in order to create a worksheet. So we go here and creating a new worksheet, and tell him to import the data, to import the total Bouguer data. Okay, and say open, Here the data is imported, then we'll try to take them or copy them to the Excel sheet. Okay, now the data of the total Bouguer anomaly is pasted inside the Excel sheet. Now we need to import the regional data, so we open a new worksheet and file, import the regional Bouguer data and open them. Now we take just the C column because A and B are already copied and installed inside the Excel sheet, so we take the C column and copy it and go to the Excel sheet and paste it. Now we have the total and regional are both columns C and D. Let's do the operation or the subtracting operation in the column E. So let's say it equals column C minus value minus column D value, and enter. Now the residual value for the first cell is, or for the first grid, is calculated. Just to double click on the cross or the black cross, then we get all the values get calculated, and this file is also required to be saved inside our yellow folder, which includes all data analysis of gravity analysis, and let's name it residual calculations. And save it. Okay, what is required right now is to open a new Excel sheet and get the data, which is the A and B, which are the X and Y data, copied to the new sheet, paste them, then taking the data of the residual or calculated residual values and paste it on C. Then we save this file also inside the yellow folder, which includes all the data analysis of the gravity, and name it as residual Bouguer Excel sheet, Excel file, and save. Now we can save and close the Excel files and go to our plot, also this one, close all files. Then we go to our plot where we deduce the total and the regional fields, and we try to plot the residual field. Now we go to grid and data and take the residual Bouguer Excel sheet, open it, and choosing the kriging method again, let's name the file as the residual Bouguer grid, GRD. So, and save it. Okay, the software will start to calculate the grid of the residual field, then say okay. And now we can plot the contour map which related to the residual Bouguer anomaly. here is the map which related to the residual Wadhah anomaly. Now we can compare between the total and residual, and we can see also some details which appeared in the residual map hasn't available before, because we have here some anomalies, new anomalies which related to the sedimentary cover which located over the basement rocks, and they weren't obvious before doing this operation. It's preferable here to give a scale color and a constant scale color for all the three maps in order to compare between them, so, or among them. So you can see here, let's choose geology, the same style of coloring, and here we also choose the same style of coloring in order to compare and make. Let's see here, the data of the residual is different from the data scale of the total, and also the colors and the maximum anomaly and the negative anomaly and the positive anomaly shape and position is different. And how can we ensure that? We can ensure if we do a profile across across the area in a constant or in a constant, yes, position. Let's add a profile. Let's say this profile starts from distance 40 here to distance 80. Double click, and then we have a profile for the total. We have a profile for the total field. Then we can compare it with the regional field. Right click, add a profile in the same position, and here is the regional field. Then we do the same for the residual field. Right click, add a profile. We have a profile in the same position, in the same, and we can compare between them and see some details which appeared in the residual field, which are really different from in value from the total field. And maybe in other lectures we'll try to apply the first derivative and second derivative and the gradient operator in order to see the lateral variation, or the variations which happens abruptly in within the data, and this will make it easy to discover some subsurface geological features like faults or other structures which are within the sedimentary cover. Thank you very much for listening, and have a good time.